All right, let's talk about one of the coolest new things happening in AI right now. We're going to dive into how we can teach an AI to read and understand your stuff, your documents, your reports, anything, and do it in real time. Let's break down how this actually works.
So you've got this amazingly powerful AI, right? But have you ever tried to ask it about, say, a report your company just published? Or even just a brand new PDF you found online? Yeah, you probably hit that wall where it says something like, sorry, my knowledge was cut off in 2023. It's a huge problem, and it really limits what we can do with these models.
So, how do we fix this? Well, the solution at its core is beautifully simple. We just give the AI a library card. Yep, that's the big idea. Instead of only having access to that huge but static library of the internet it was trained on, we give it a special pass to a private collection, your documents. Now, this whole process has a bit of a fancy name, Retrieval Augmented Generation, or what everyone just calls RAG. You can think of it as a just-in-time information system for the AI. It's not permanently learning your document. Instead, it's like having a research assistant that finds the exact right paragraphs to read, right at the moment it needs them to answer your question. It all breaks down into three main stages. First, the system retrieves the most relevant bits and pieces from your documents based on what you asked. Second, it augments your original question by basically stapling that new context right onto it. And finally, it sends that whole package to the large language model and asks it to generate an answer. But now it's armed with all this super specific relevant info. So this whole thing really happens in two big phases. There's a one-time setup job called indexing. This is where all your documents get loaded up, chopped into smaller pieces, and neatly organized. After that's done, you move into the query phase. And that's where that retrieve, augment, generate loop kicks in every single time you ask a question. It's a really smart and efficient system.
Okay, but how does that retrieve step actually work? I mean, how does an AI know which sentence in a 100-page document is the one that's relevant to your question? Well, the secret lies in turning words into numbers.
The best way to picture this is to imagine a giant multidimensional map. But instead of mapping out cities and roads, this map plots out meaning. Every single piece of text, whether it's one word, a sentence, or an entire document, gets its own specific coordinate, its own spot on this map. And that location is determined purely by what it means. These coordinates have a technical name, of course. They're called embeddings. An embedding is basically a long list of numbers, a vector, that captures the semantic meaning of a piece of text. So what we're doing here, and this is the key, is we're translating the fuzzy human concept of meaning into cold, hard math that a computer can actually work with. And the result is pretty amazing. You get this meaning space that organizes itself just like a real library. All the text with similar meanings ends up clustered together in the same neighborhood. So a document chunk talking about golden retrievers will be way closer to one about German shepherds than it will be to one about, rocket science. Okay, so we've got our map of meaning, and everything has a coordinate. But how does the system figure out what's closest? It's not as simple as just pulling out a ruler. The trick involves a little bit of geometry. The way we measure this closeness is with a concept called cosine similarity. And here's the thing, it's less about distance and more about direction. This chart here shows how similar a question is to different chunks of text. The higher the score, the closer the meaning. A high score just means the vectors for those two bits of text are pointing in almost the exact same direction. This makes the difference really clear. When we think of distance, we're usually thinking of a straight line between 2 points. That's called Euclidean distance. But in this meaning space, we care way more about the direction of the ideas. Cosine similarity is perfect for this because it tells us if two sentences are talking about the same concept, even if one is really short and the other is long and detailed. It's all about the angle. Now, this all probably sounds incredibly complicated to build from the ground up, and honestly, it is. But the good news is, developers have some amazing tools that make this whole process way, way easier. Let's talk about one of the biggest ones out there, LangChain. Think of LangChain as the ultimate toolkit for building these AI applications. It gives you all the pieces you need right out of the box. You've got document loaders to read your files, text splitters to chop them up, embedding models to turn that text into vectors, and vector stores to keep everything organized and searchable. It lets developers focus on building cool stuff, not reinventing the wheel every time. So, with all of this, we've essentially given AI a new superpower. It's the ability to read and understand any information we want to give it.
It can become an instant expert on your team's code, your personal notes, or even today's news. That old knowledge cutoff problem is no longer a hard limit, which leaves us with a really fascinating question to think about. Now that AI can read anything we give it, what should we teach it next?